Let's say if you have y is equal to x squared. Now we're going to be talking about the transformations of a function. So what are transformations, first of all? They're just kind of ways to kind of change the function. They're just kind of ways to move the function around. So in this case, if I have y is equal to x squared, let's say I did y is equal to x squared plus 1. Well, what happened there? Well, my function moved up by 1 unit. So every y value that I had, well, in the green graph, it's just 1 unit higher. If I, let's say, added 2, well, then it's 2 units higher. If I added 3, it's 3 units higher. So when you add, in this case, to the end of this function, if you add to the end of this function any sort of kind of amount, well, it's going to move it up by that amount. So if I add 3 to the end, it's going to move it up by 3. Likewise, if I subtract, subtracting moves it down. So minus 4, minus 5, right? If I subtract 5 from it, I move it 5 units down. Adding moves it up, subtracting moves it down. Now, what if I did something inside the middle of this? Kind of inside the function. What happens if I put a minus 3 here? Oh, it moves it to the right. So whenever you subtract on the inside of the function, it's going to move it to the right, to the positive side. This might be confusing at first because, when you're subtracting something, you normally would think, it might be associated with like the negative side, but it's always kind of like the opposite of what you expect. When you're subtracting, in this case, inside the function, you're moving it to the positive side. Likewise, if you're adding inside the function, you're moving it to the negative side. So let's say if I subtract 5 from this, I'm going to move it 5 units to the right, to the positive side. If I add 6 to it, well, I'm going to move it to the left 6 units. So that's kind of some basic transformations of functions. So if I have, and actually you can have combinations of this. So you can say, if I have y is equal to x minus 3 squared plus 7, well, what happened here was this x minus 3 squared part moved it 3 units to the right. And then after that, this plus 7 moved it 7 units up. So you can have kind of combinations of these two kind of transformations. You can have combinations of transformations. Let's do another example. If I have, let's say, y is equal to, let's say if I have y is equal to x minus 6 squared minus 9. How will this function look compared to the first function? So this x minus 6 squared part is going to move it 6 units to the right, and this minus 9 part is going to move it 9 units down. Now let's say if we have y is equal to the square root of x. So once again, the same thing kind of applies for the square root function, right? If you add 7 to it, moves it up. Subtract 7, moves it 7 units down. If you add on the inside, it moves it to the left. And if you subtract on the inside, it moves it to the right. It moves it 3 units to the right in this case. Now, something weird goes on. Let's say if I add a negative right over here. Well, what happens is it kind of flips around the x-axis. The reason why is because, well, you'll notice how every value here is positive in this case. Well, when I add a negative sign to it, well, a negative times a positive makes a negative. So all of those values become negative. So they swap signs. So it goes from positive to negative when I add this negative sign on the outside. Now, when I add a negative sign to the inside, oh, look what happens. It reflects about the y-axis. So, and just to recap what happened there. When I added a negative sign to the outside, I flipped it around to the, reflected it across the x-axis. But when I added the negative sign to the inside, I reflected it across the y-axis. Now, why does this work? Well, in the original, y is equal to the square root of x. So if we were taking a look at this function, we know that x cannot be equal to a negative number. X cannot be equal to -1, right? Because if it's -1, well, it can't be represented on this x and y axis with real numbers. We'd have to use another type of graph for this, which I'll talk about in a later video. But the main point is we can't represent kind of the square root of a negative number on a real x and y axis. We can't represent it. we can only stick to the positive options. So if you have y is equal to negative x, well, in this case, if we plug in the negative number for x, let's say negative 4, well, what happens is this negative right here is going to cancel out the other negative, making it a positive. So this is why, this is why in this case, y is equal to negative x only works with negative numbers, because now the negative from the negative number cancels out the other negative inside the square root, making it positive. So just a quick recap of what we've done. If we have a function like f of x is equal to the square root of x, well, f of negative x is going to be equal to the square root of negative x. In case this doesn't make sense, we know that if we have f of x is equal to the square root of x, f of 1 is equal to the square root of 1, right? So everywhere we see x, we replace it with a 1. So if we have f of negative x, well, everywhere we see x, we replace it with a negative x. So this is equal to the square root of negative x. And we said how this reflects it across the y-axis, right? So if we have y is equal to, or f of x is equal to the square root of x, we have f of negative x is just going to be the square root of negative x, right? Which reflects it across this y-axis. We said how if we have f of x is equal to the square root of x, well, negative f of x is going to be equal to the negative square root of x. And in case you don't understand this, well, if we know that f of x is equal to the square root of x, well, we can substitute it in here. So we just get the negative square root of x. And we said how whenever you put a negative sign in front of this, well, this is just going to reflect it across the x-axis. So in this case, negative f of x is here, and this reflects it across the x-axis. Also said how if we add to the end of our function, we move it up. If we subtract it, well, we bring it down, right? So in this case, if I add 7 to the square root of x, I get the square root of 7 plus, the square root of x plus 7, which moves it up 7 units. So we have the square root of x. Well, if I add 7 to this, I move it up by 7 units. Likewise, if I subtract 7, I move it down. If I have f of x minus h, I move it to the right by h units. So if I have, let's say, the square root of x minus 3, I move it to the right by 3 units, right? If we know, in this case, if we know that f of x is equal to the square root of x, and let's say if I have f of x minus 3, well, this is just going to be equal to the square root of x minus 3, and that means that we're going to move the function to the right by 3 units. Likewise, if you add to the function, it's going to move it to the left. So adding to the inside of the function moves it to the left, in this case by 3 units, 10 units,